is going to be objective 25. We are going to evaluate functions today, and we are going to find compositions of functions. Okay, I'm going to start out slow. So I'm going to start out with Algebra 1 material, and then we're going to slowly build to the Algebra 2 stuff. Okay? Any questions on what we're doing? All right, does everybody have this? All right, so let's look at example 1. I'm giving you a function f at x is equal to x squared plus 5x minus 2, and I want you to find f at 3. Okay, yesterday we talked about what is f at x. F at x is equal to y. So the question I'm asking you is, I want to know the output. I want to know the output when 3 is the input. So normally we have f at x, but now we have f at 3. So what do I want to do? I want to replace x with 3. So I'm going to take a 3 and I'm going to plug it in for both x's. So this is going to be 3 squared. Make sure you plug in with parentheses. I cannot stress that to you enough. And so work that out for me. 3 squared plus 5 times 3 minus 2. $22. So if you worked it by hand, you would have to work PEMDAS. So this would be 9 plus 15 minus 2. Then left to right, you would get 24 minus 2, which would be 2. Okay, and so you can put that all into your calculator. So when my input is 3, my output is 2. Any questions on that? Input is x, output is y. So when the x is 2, or excuse me, when the x is 3, then the y, the output is 2. Oh, 22. Thank you. Sorry. All right, example 2. So I'd like for you to do this one for me. G at x is equal to 3x minus 4. I want you to find g at negative 8. So I changed it this time and I made it g of x because you're going to see f at x, g at x, h at x, l at x, k at x, m at n, a at b. You're going to see all kinds of different variables. It's all y. Okay? It's the output when what's the input? Negative 8. So I'm just going to plug in. And when I work this out, what do we get? Negative 28. That's the easy part. Okay? This is like Algebra 1. Are we ready to go to Algebra 2 now? So same concept, except now we're going to plug in an algebraic expression. Okay? So we have k at a is equal to 3a plus 2. I want to find k at y minus 2. So I want to know the output when what is the input. What would we be plugging in this time? Y minus 2. So what I'm going to do is I'm going to have k at a is equal to 3a plus 2. I'm going to, wherever I see an a, I'm going to plug in y minus 2. So 3 times y minus 2 plus 2. So this is substitution. I'm exchanging the a for y minus 2. Does that make sense? Okay, so make sure the a comes out and the y minus 2 goes in. Now, this is going to be equal to 3y minus 6 plus 2. What can I do from there? The negative 6 and the 2, so 3y minus 4. And I'm finished. Now, we had the discussion earlier today on what goes on the other side. Well, we know it's the output, right? It's the y. But be careful because I'm plugging in y for the input. So be careful when you say y equals 3y minus 4, because some people would say, can't you move that y over there and combine like terms? This y is different than that y. This y is meaning the output. Do you understand that? So what you may want to do in this case is you may just want to leave this. What am I plugging in for a? I'm trading the a for y minus 2. This is what I'm searching for. I'm searching for the output when y minus 2 is the input. And someone said earlier, so does that mean like we work this part out? Do we distribute the k to the y and the k to... No, this part over here is just saying the output. So you can say y, you can say k at a, you can say k at y minus 2. The output when y minus 2 is the input. This is the side you actually plug in and work out. Do you understand that? So I would not distribute that and work that out. This is just referring to the output. The answer I get when I plug y minus 2 in. Thumbs up if that makes sense. Thumbs in the middle if you're like, Okay. Um, 9 examples total today. So I want to find, I've given you the function h at n is equal to 2n squared plus 2n. But I now want to find h at n plus 3. So what does that mean I'm plugging in? I'm plugging in n plus 3 everywhere I see an n. I'm going to plug it in there, and I'm going to plug it in there. So 2 times n plus 3 squared plus 2 times n plus 3. Does everybody understand what I did? I still have the same function, except what did I do with the n? I took the n out, and in its place, I plugged in n plus 3. Okay? So we're going to evaluate this. We got to simplify it. What does that mean I do with this? Do I distribute the 2 to each of those? No, you got to write it twice. So this is going to be n plus 3 times n plus 3 plus 2 times n plus 3. Some of these are more complicated than others. This is one that has a little bit more step to it. I do not want you to be afraid of it. You have done this before. This is a good review for us. Remind me, how do I multiply 3 things together at once? Schmack? Schmack. Okay, I'm going to take 2 of them, multiply them together, get an answer, and then I take that and multiply it with the third part. So if it were me, I would FOIL this together first. Then I would distribute the 2. Do you have to do it that way? No. But you can only do 2 things together at one time. So this will be n squared plus 3n plus 3n would be 6n plus 9. Now that I have an answer, I'm going to distribute the 2. So 2 times n would be 2n squared. 2 times 6 would be 12n. 2 times 9 would be 18. Over here, I'm going to distribute. 2 times n would be 2n, and 2 times 3 would be, then, what can I do? Combine like terms. So 2n squared plus what? 14n plus what? Plus 24. and there you would be done. So h at n plus 3, again, the left side is going to stay h at n plus 3 because it's saying here's the output, here's the y. If you want to write y on this one would be okay to write y on because then you wouldn't get confused because it's using an n for the input. But h at n plus 3 is equal to 2n squared plus 14n plus 24. The question is, do you want to go further? Like you could factor out a 2, and then you could try to factor it into binomials. Would you want to do that? Why not? When do we want to factor further? When it can help us do what? When something would cancel. Even if I factored that, would something cancel? Then why do it? You understand what I'm saying? Don't factor it further. You totally could factor it further, but nothing would cancel. So I would just leave it as is. Someone earlier today, they made it y equals, and they made it a quadratic equation. And you know what they started doing? They started trying to do the quadratic formula. I'm not solving an equation. I'm not asking you to do that. I'm just asking you to plug in and simplify. PEMDAS, multiply, simplify, combine like terms. And so there would be your answer. Does that answer the question as far as, was anybody thinking, let's factor it further? Nuh-uh. Okay, so let's go to this, and this will be a good stopping place for lunch. Okay. So what we're going to do is we're going to look at a composition of functions. In a composition of functions, the results of one function are used to evaluate a second function. So basically, we take one function and use it to plug into a second one and evaluate it. So you're plugging one function into another. There are two ways to write this, and I need you to be familiar with both. One way, it has a little circle there. This means composition. And to me, it looks like it says fog. This means the composition of f at g. I prefer to write this as f at g at x. That's the way I like to write it, f at g at x. These are the same thing. F at g. That means evaluate the function f when you're using g as the input. And we'll talk about that when we get back. And you can reverse that. G at f would be the same thing as what? G at f at x. You need to be familiar with both. You could possibly see both on different things, different worksheets, the SOL. So make sure you are familiar with both ways. Okay, so we'll pause there till we get back from lunch. Let's see what we got. So we are back from lunch, and we're going to see what we got with example 5. So we're going to do both of these. The first thing we're going to find is we're going to find f at g at x. F at g at x. Before I begin this, I'm going to tell you, if you will take this one step at a time, you'll be fine with this. But if you look at it like all at one time, it's going to get really confusing. So, like, tell me this. If I had f at 3, what would I be plugging in? I would be plugging in 3 into what? Into the f at x function, right? I would plug it in right here into the a. So look at this. The only thing that is different is that I now have a g at x function. So you're going to start on the inside. I'm going to take the g at x function, which is what? 4a. I'm going to take 4a, and I'm going to plug it into the f at x function. You start on the inside, g at x, and plug it in to the outside function. So my outside function is 2a minus 5. So what I'm going to do is I'm going to take my g at x, everybody understand that? And I'm going to plug it in to the f at x. I'm going to take the 4a and plug it into the 2a minus 5. I'm going to take one function and plug it into the other. And then I'm just going to evaluate. So I'm going to take the a out, and in its place I'm going to put in 4a. So then I'm just going to simplify. So this would become what? 8a minus 5. And that is what f at g at x is equal to. Right. Well, it's just that we're now naming what we're plugging in. One function into another function. So let's reverse that. Okay? You might not always do, like everybody says, how do I know to use the second function into the first function? Why didn't I plug the first function into the second function? Well, you could. It depends on how it's written. You start on the inside. This is what we're plugging in. So we're going to plug in the g at x function into the f. So I started with the g at x, which is 4a, and plugged it into the f at x function. If I reversed that, let's find g at f at x. So what's my input this time? What am I plugging in? Right, the 2a minus 5. Very good. And if you wanted to, you could write it this. You could replace the f at x with 2a minus 5. This is your input. You are going to be plugging in 2a minus 5 into the g function. What's my g function? 4a. So this is my input, and I'm going to plug it into this function. So this would be 4 times 2a minus 5. And then I'm just going to simplify it, and I would have 8a minus 20. So g at 2a minus 5 is equal to 8a minus 20. Thumbs up if you followed, thumbs in the middle if you're kind of iffy, thumbs down if I totally lost you. Please give me a thumbs. Which way? Middle, middle, up, up, middle, middle. Okay, so no downs, no downs. So good. Let's do another one. Okay. They're both. It depends on, I did both because I want you to be familiar. You won't have to do both. If I said find g at f at x, this would be the answer. 8a minus 20. If I said find f at g at x, then the first one would be the answer. We just did both. And because how will you know which one to do? The directions will tell you. Okay, the directions will tell you which one to do. So here we go. I'm going to give you the directions. I want to find g at f at x. So everyone says, I don't know which one to start with. Oh, like sequences in series? Plugging in one, it's similar. I mean, you're substituting, you're plugging in. Does that make sense? We're using one and plugging into another. So, yeah, similar, just slightly different. Okay, so which one do I start with? How do I know which function to start with? Okay, so let's start on the inside. Let's start with f of x. And so I do agree. What is f of x? X squared plus 2. And we are going to plug that into the g function. Which one's the g function? The g at x function. X minus 6. So I'm going to take this input and plug it in for that x. Where does this x go? It goes out the door. Okay, that x goes out the door. The x squared plus 2 goes in its place. Okay, it is substitution. So what would I plug in? X squared plus 2 minus 6. Then how could I simplify it? You can combine 2 minus 6, so x squared minus So g at x squared plus 2 is equal to, when the input is x squared plus 2, the output is x squared minus 4. Okay, what I would like to do, though, is I want to reverse it. What if the direction said find f at g at x? So I want you to attempt that one. I want you to start with, which one would you start with? The g at x function, which is x minus 6. Very good. And you're going to take x minus 6 and plug him into x squared plus 2. Take the x out and put the x minus 6 in its place. So try that now. So let's check it out. So not as hard as it looks, if you'll take it piece by piece. So first things first, everybody says, I don't know which one to start with. Start on the inside. We're going to start with the g at x function, which is x minus 6. And we're going to take it and plug it into the f at x function, which would be x squared plus 2. So this is our input. We are going to plug this in for that x. So this is going to become x minus 6 squared plus 2. You can't distribute it because it's a binomial. You'll have to write it twice. So this is going to become x squared. The outer and the inner makes negative 12x plus 36 plus 2. And then when you combine like terms, you'll get plus 38. So, and someone said, do you say f at x minus 6 or do you say f at g at x? Doesn't matter. No, it's the output. The output, when g at x is the input, is equal to x squared minus 12x plus 38. How many knows where they went wrong if you didn't get it? Yes? Okay, so I would like for you to try this one on your own, okay? Got 9 examples total today, and you guys are doing really well. Let's first start with g at f at x. And again, everybody says, well, how will we know which one to do? It will tell you which one to do. The only reason we are doing both g at f at x and then switching it, doing f at g at x, is so you can have practice with it. Didn't hit play. All right, so we're going to start with this one. I'm going to start on the inside with f at x. So we're going to take this trinomial and plug it into 2x minus 1. So I'm going to take all of this and plug it into that. You know what helps me? What's one thing that I'm doing that helps me? Like I circle my input and I draw an arrow where I'm going to plug it in at. I don't know why that helps me, but that helps me. Okay, so this is going to be 2 times 3x squared minus x plus 4 minus 1. So then this will be 6x squared minus 2x plus 8 minus 1. And then if you combine like terms, 6x squared minus 2x plus 7. And that is equal to g at f at x. How many were able to get there? Now you're like this? All right. Thumbs up if you're good with it, thumbs in the middle if you're still iffy, and thumbs down if, like, it's not good at all. Okay, good. So, reverse it. I want you to do f at g at x. Reverse it. I want you to do f at g at x. Okay. All right, f at 2x minus 1. We'll come back to that. I'm going to plug it into 3x squared minus, you know what I would suggest on this? Minus what? Minus 1x, because that's going to help you when you distribute a negative 1 into it. So follow along. I'm going to take, this is my input, and I'm going to plug it in here and here. So 2x minus 1 squared minus 1 times 2x minus 1 plus 4. How many successfully got it plugged in? Good. Now from here, you have to write this twice. All right. How do you multiply three things together at once? You got to do 2 together first. So I'm going to FOIL together first, and I'm going to make 4x squared. My outers and my inner makes negative 4x plus 1. I'm going to go ahead and distribute and make that minus 2x plus 1 plus 4. And there's a 3 in front. Then I'm going to distribute and make 12x squared minus 12x plus 3 minus 2x plus 1 plus 4. Then I'm going to combine like terms. 12x squared, what will this make? Negative 14x. What's 3 plus 1 plus 4? Plus 8. And so f at g at x is equal to 12x squared minus 14x plus 8. How many were able to get all the way there? A couple. All right, question, Landon. Did you not? I'm guessing this right here, this is a helpful key, because I'm guessing when you plug in for x right here, did you distribute a negative to the inside of that? And that's probably, that can be where you probably went wrong. Okay, does everybody understand that that's a negative 1? So when I plug in, I'm going to have to distribute that negative 1 to make negative 2x plus 1. Okay? Any other questions? All right, let's wrap this up. I got 2 more to go. I think you will be fine with this. But I'm giving you, this is different. I'm giving you 2 functions. I'm giving you g at x equals negative 2x plus 1 and f at x equals 5x. And my directions are, I want you to find f at g at negative 2. Everybody focusing with me? So, if you'll take this piece by piece, you'll be fine with it. Where do you think I should start? We should start with the negative 2. We're going to start on the very inside. And we are going to take negative 2 and plug it into who? G. And that's all I'm going to do right now. I'm going to take negative 2 and plug it into the g at x function. So let's take the g at x function, and then we're going to find g at negative 2. So I'm going to plug in negative 2 plus 1. So negative 2 times negative 2 would be 4 plus 1. So what's g at negative 2 equal to? 5. Now we know that all of this right here is equal to 5. So what do you think we should do with 5 now? Plug it into, if I replace it, look what I substituted. Everybody agree that g at negative 2 and 5 are equal? Because that's what we found right here. They're equal. So now I'm going to find 5 at f. Okay, or f at 5. So f at 5 is equal to 5x. So when I plug in a 5, that's going to be equal to 25. So we started with the very inside. We took negative 2 and plugged it into g. Got an answer. Then we took that answer and plugged it into f, the outside. Kind of reminds me of like a domino effect. Like you start with one and then it touches the other and then it goes to the outside. So you started here and it goes to G, you get an answer and then it goes to the F and you get your final answer. Okay? So last one, you try this one. I want you to find G at H at 3. G at H at 3. Where are you going to start, Frankie? And we're going to plug him into which one? Well, we're going to plug him into, what does it say? H at what? So we're going to plug it into the H function, which is this one. And then you're going to take your answer and plug it into the G function. Because this says find H at 3 first. My top one is a G function. I'm trying to find H at 3. You plug in what you get once you figure this out. So I'm going to take 3, listen carefully, and I'm going to plug it into the H. So I'm going to find H at 3. So I'm going to plug in 3 into the H first. And when I do that, that becomes 9 plus 18 plus 8. So that's going to equal 35. So H at 3 is equal to 35. So we know this amount right here. Check this out, guys. This amount, H at 3, is equal to 35. So now I'm going to find G at 35. So I'm going to go to my G function. And I'm now going to plug in 35. So I get negative 70 plus 1, which is negative 69. So G at H at 3 is negative 69. Okay, how many were able to get that? Gotcha. You take 1, plug it into the first, get an answer, then take that and plug it into the second. Sing you this